Well, we have found ourselves in 10.4, the divergence and integral test. We will begin with a divergence test. It will test to see if a series diverges. Notice it is not called the convergence test. So here it is. Theorem 10.9, the divergence test. If the sum of a sub k converges, then the limit is k equals infinity of a sub k is equal to 0. So that is if this, that implies that the limit as k goes to infinity of a sub k is equal to 0. It does not say that if the limit goes to 0, then it converges. This is a one-way street. Also, we're not talking about convergence. The name of the damn thing is divergence. This is what we care about. This first part, you can kind of ignore it. Equivalently, if the sum, or not the sum, if the limit of the sequence doesn't go to 0, then the series diverges. If the limit of the sequence goes to 0, it tells you absolutely nothing. This is a one-way street. One way, not two ways. Okay, let's check it out. Hey, shut up over there, dog. I'm so mean to him. He's so old and smells so bad. But I tell him he's so beautiful. You're so ugly, boy. And there he goes. Sorry for the noise. All right, so we're going to take these 4 problems and we're going to determine whether the following series diverge or state the divergence test is inconclusive. Because the divergence test does not, this is one of the most common misconceptions, the divergence test doesn't show if something converges. It shows if something diverges. Goes to infinity or does not exist. So we have these 4 sums. Let's look at our first one. So the game is, we want to take this and we want to take the limit as our k goes to infinity or n goes to infinity, however you want to set this thing up. But I'm going to stay consistent and just do this. It's the limit as k goes to infinity. So we just take out our sum, or the sequence that's inside of the sum. K over k plus 1. And I'm not going to do, well, screw it. Are you seeing these yet? Degree of the top is 1, degree of the bottom is 1 is the coefficients on k. If not, you can do more work and do L'Hopital's if you feel like it, but I would prefer if you just stated that that goes to 1. You know, so derivative on k, 1. Derivative on k plus 1, 1. It's equal to 1. 1 does not equal 0. Therefore, the test, or actually, so since it doesn't equal 0, that confirms the divergence test. Therefore, this diverges by the divergence test. All right, it went to 1. It didn't go to 0. So if it ever goes to any number other than 0, when you take the limit of the sequence inside the sum, if you ever get it anything other than 0, it diverges. That's good news. Let's go to our next one. So we have, all right, so we're going to take this out, this part right in there. Limit as k goes to infinity of 1 plus 3 over k over 2 to the k. We want to see what's going on. So we're like, okay, let's check it out. Oops, I want to write next there. So, do you mind? Oops, looks like an equal sign. Can I break this up into 2 pieces? Got to have that trick down. And now if we go further, the limit as k goes to infinity, we have 1 over 2 to the k, minus the limit as k goes to infinity of 3 over 2 to the k. Hey, wait a second. I'm pretty sure that base, that thing's bigger than 1. That's bigger than 1. Ooh. Therefore, this is going to, well, if you look underneath, that goes to 0, right? You take that limit of any number less than 1, and you take the limit as k goes to infinity, raising it to a power. Yeah, it's going to go to 0. That goes to 0. Now this part here, this goes to Oh, shoot, that goes to infinity. Because 3 over 2 is larger than 1. Therefore, this goes to infinity. And infinity, I'm pretty sure, doesn't equal 0. Therefore, it diverges. All right, didn't equal 0. So, boom, it diverges. That's the divergence test. If it does equal 0, it doesn't tell us anything. So let's go with our next 2. So we're looking at it, we're like, all right, well, let's take our a sub n out of there, or the sequence. The limit as k goes to infinity of 1 over k, and come on, do that 0. Oh, okay, so we should say it converges, right? No. Test is inconclusive. It tells us nothing. And then we go to our next, and we're like, oh, let's do the same thing. I wonder what's going to happen here. You should already know the answer. That's 0. Therefore, the test is inconclusive. Now, you're not going to find this out yet. Well, in a second you might. This will diverge, by the way. That's going to diverge, even though the limit goes to 0. But that's not what the divergence test says. It says if it doesn't go to 0, we know for sure if the limit doesn't go to 0, we know for sure it diverges. But if the limit does go to 0, it doesn't tell us anything. It still could diverge. And it happens to be that is what we call a harmonic series. And it actually diverges. So you're like, well, then this one must diverge. Actually, technically, that one does. That one converges. That one will actually converge. Once we learn something called the p-test, you're going to like the p-test. And get your mind out of the toilet, huh? Well, p is the number. We're going to learn a little power rule with it, where we're going to be able to just look at that and go, bang, it converges. And we'll look at the one that's in pink and go, boom, that diverges, because we're going to have a little test. All right. There it is. There's our first parts. So let's just go a little further. Let's talk about that 1 over k. Sorry, I'm so far down here. It even has a special name. Look at that. You know it's fancy. You know we're being fancy when it's got a special name. So there's a whole proof behind this. And we're going to say that the sum of 1 over k, from k equals 1 up to infinity, diverges, even though the terms of the series approach 0. Or I like to say the sequence, the limit of the sequence that's inside of the series, approaches 0. Now, let's think about this. Can I write this just a little different? Can I write this a little different? I want to write it as 1 over k, and then the limit is n tends towards infinity. Remember that? Remember that? I think you remember that, don't you? Well, dude, wait a second. Wait a second. Isn't that the integral from 1 to infinity of 1 over x dx? Isn't that the same thing? That's the definition of an integral. Oh. And doesn't this just go to, oops, I'm jumping steps, gotta write it all proper. And then we write, the limit is, b goes to infinity from 1 to b of 1 over x dx. And then isn't this gonna be ln of b minus ln of 1? With the limit as b goes to infinity? Oh, it's hard to write. So we have ln of infinity. Don't ever write that. Don't ever write that. I'm just being ridiculous. So this is infinity minus 0. So it goes to infinity. It diverges. Remember, these sums and these integrals are tied together. So that's essentially why that's true. So we have the same piece. So looks like this is going to work. And it's like we learned this little p-test when we were back in chapter 8. It's the same thing. We're just building upon what we learned before. Learning stuff just long enough to take a test, and then forgetting it. Not good. Not good. Very important that we have this stuff down. So, yeah, buddy. I think that's it. And we'll come back and we'll mess around with the integral test in just a moment.